Hi, this is Ms. Fitzmaurice, and video is an explanation of the problem on page 3 of your review packet. So as usual, you should spend 10 minutes and 10 minutes only trying this, and then check back with the video. Okay, so the problem says a coin C of mass 0.005 kilograms is placed on a horizontal disc at a distance of 0.14 meters from the center as shown above. The disc rotates at a constant rate in a counterclockwise. Okay, so part A says to draw and label the vectors for acceleration and linear velocity. So we know that this thing is moving around in a circle. If something is moving around in a circle at a constant speed, we know that acceleration has to be towards the center of the circle, and instantaneous velocity, and I'm going to draw the path that the coin takes, is tangent to the circle that the object is moving around. So AC should be towards the center, and tangential velocity is, of course, tangent to the circle. Okay, in part B, they want us to find the linear speed of the coin. Okay, so what they're really asking is for us to calculate VT, and we know that VT is equal to 2 pi r divided by t. Okay, it tells us that it takes 1.5 seconds to get around, and so VT is equal to 2 pi divided by 1.5, and we know that the radius is 0.14. And when we put this into a calculator, we end up with VT is equal to 0.59 meters per second. In part C, it says the rate of rotation is gradually increased. We know that the coefficient of static friction, so mu, is equal to 0.5, and we want to know if the coin is just slipping, how fast does it have to be going? Okay, so to think about this, we're going to draw a force body diagram of the situation, and this is going to be a side view. Okay, so the center of the circle will be over here where this X is, and this dot is the coin. Of course, gravity is acting down on our coin. It's sitting on a flat surface, so Fn points straight out, and friction has to point towards the center. Now, if the coin is just barely slipping, okay, that means that Ff, our friction force, is equal to exactly mu Fn. Okay, so we can write out Newton's second law for both x and y. So in the x direction, sigma Fx equals max. We only have Ff, so we have Ff equals max, but we know that this thing is moving around in a circle, so ax is ac, our centripetal acceleration, which is equal to vt squared over r. Okay, we can of course plug mu Fn in for Ff. Okay, now we have numbers for almost everything except for Fn. We have a number for mu, we have a number for m, we have a number for r, and we're solving for Vt. So to find Fn, we use the y direction. We have sigma Fy equals may. Fn minus Fg equals may, but of course this thing is not moving up and down, so ay has to be 0. And we have Fn is equal to Fg, which is mg. Okay, so we're going to take this mg and plug it in for Fn up here. So we have mu mg equals m vt squared over r. Okay, it turns out the mass doesn't even matter. We can cancel the masses out and solve for vt algebraically. When we solve for vt algebraically, we get vt is equal to the square root of mu rg. Okay. Now we can plug in numbers, so we have vt is equal to the square root of 0.5 times 0.14 times 10, and we find that maximum speed is equal to 0.84 meters per second. Okay, so in part D it asks, if the experiment in C were repeated with a second identical coin glued to the top of the first coin, how would this affect the answer to part C? Okay, and so gluing an extra coin doesn't change the coefficient of friction, it only changes mass. But the m's cancel out, and if we look back to C, we see that Vt is this thing, the square root of mu Rg, so there will be no effect. All right, so in terms of grading, give yourself 1 point if you indicated the correct direction for AC and 1 point if you indicated the correct direction for VT. For part B, if you used 2 pi r over t, give yourself 1 point, and if you got the correct answer, give yourself 1 more point. All right, so for part C, give yourself 1 point for the correct force body diagram. Okay, give yourself 1 point if you used Newton's second law at all, so sigma fx or sigma fy. Give yourself 1 additional point if you got to this part right here, where you have mu fn is equal to mvt squared over r. And then finally, give yourself a point if you got the correct answer. In part D, give yourself a point if you realized that only the mass changes and you wrote that down, and give yourself a point if you said there would be no effect and you justified it.